Hi, I'm Nova from WattWitness, the trust minimized electricity meter protocol. When it comes to tokenization, there has been a lot of promise, but unfortunately very little progress in recent years. In my experience, this is largely due to the fact that in basically all first world countries, KYC requirements for security tokens create markets that are illiquid, inefficient, and exist kind of in this walled garden. In most lesser economically developed countries, on the other hand, there's oftentimes no regulation surrounding the issuance of security tokens. However, there's also basically no investor protection, and authorities meant to establish trust between parties are too often bribable. I was talking to a friend of mine who runs a small solar farm in Guatemala about the possibility of maybe tokenizing it. And while he instantly seemed interested in the idea, it didn't take us long to run into the aforementioned problem. Solar parks have been used as fronts for Ponzi schemes time and time again, both on-chain and off-chain. So how would we then prove to our investors that our solar park is operational and productive without relying on regulation or auditors? Here's what we came up with: a hardware device that cryptographically signs electricity meter data at the source and records these readings on-chain. The hardware setup looks as follows. We use an electricity meter which monitors real-time electricity production. This data is broadcast to an ESP32 microcontroller, which uses a secure cryptographic element to sign it. From here, the readings are transferred to a local database on our Raspberry Pi, from which it is sent on-chain every 5 minutes using Chainlink functions and automations. So here we have the Shelly electricity meter, which takes real-time readings, sends it over to the ESP32 microcontroller, which signs it using our SparkFun chip here. And from there, it's sent to our Raspberry Pi, which saves it in a local database, from which it is sent on-chain. Coming now to our dashboard, which can be accessed from WattWitness.com. Here, we display the near real-time data from the Raspberry Pi, along with some useful statistics and status indicators, like the signing public key of the secure chip and the time since we last received a reading. In the top right, we included a module to allow anyone to read out and verify the readings that we record on-chain. Clicking on a certain transaction shows the contained readings, and this data comes directly from our smart contracts events page. Clicking on the transaction hash will take you to an Explorer where you can check out the transaction. So we use a Chainlink functions call, automated using Chainlink automations, to trigger an API call that fetches unprocessed readings, then adds those to a Merkle tree for storage and verification. The infrastructure that we've built here can potentially empower a wide variety of use cases, from simple tokenization of CO2 certificates all the way to fractionalization and tokenization of energy infrastructure, and ultimately, hopefully, even prosumer microgrids. So to summarize, WattWitness signs smart meter data with a secure chip and stores its readings on-chain. While originally designed for the tokenization of small-scale solar projects in low-trust environments, we now realize that this could potentially be used in any use case that requires electricity production or consumption data. And while this is not the end-all be-all, we call it trust minimized and not trust less, we hope that this is a foundation for tokenization projects to start building today. Thank you for your time.